Hi everyone. Uh, at the first, we want to uh, have a little talk about the area of rectangle and then the area of the parallelogram and rectangle. So let's start the area of a rectangle. Consider a rectangle with the width of W and length of L. Uh, you the area of a rectangle is equal to its width multiplied by its length, which is quite obvious from the figure I have drawn. If we cut off this part of the rectangle and move it to the other side as I have done, so we get a parallelogram as I have drawn here. The area of this result parallelogram will be equal to the area of the original rectangle. So we will have the area of the parallelogram as the product of its length, as we name here as its base, and its width as we name it in parallelogram as its height. So we will have h multiplied by its base, we name it b. So this is the formula of the area of a parallelogram as we saw that, and we get this. Now if we divide this parallelogram along its diagonal, we obtain two triangles each having half the area of the parallelogram. So we can write that is base multiplied by height divided by 2. So we can write the area of a triangle as multiplication product of its height and base divided by 2. And now there is an important question: can this area formula be generalized to any triangle? Yes, of course. Any triangle can be transformed to a parallelogram by drawing two parallel sides. For example, you can convert this to this, and so we can apply the same reasoning as before. So let's come back to our parallelogram. What happens if you draw other triangles like this with the same base and different corner, or like this with same base and different corner, or like this? We can draw their height as a line perpendicular to the base, and their area all are the product of H and B, and they all are half of the parallelogram area, so divided by 2. And for this also we have same area, and for the third one we also have the same area formula. So any triangle will have a area half to the area of the parallelogram. What happens if we have triangles like this that divide the base of parallelogram? Here, height of triangles are same as the height of the parallelogram, and their base divided, and some of them are equal to the base of the parallelogram. So some of their areas will be half of the area of the parallelogram. And also if we have triangles like this, then again we'll have their areas again like the previous one. The same formula and relationships also hold true when we draw on the other base of the parallelogram like this. A1 and A2, A1 and A2 are half of the area of the parallelogram. Now you are ready to solve an interesting problem like this problem. Find the area of the rectangle and write it down in